Hello and welcome. Every single day, we're all relying on this silent, invisible force that keeps our entire digital world from just falling into chaos. It's not code, it's not hardware, it's time. And today, we're going to pull back the curtain on the incredible system that synchronizes it all.
But first, let me ask you something. What really happens if your computer or your phone or some server is off by just a few minutes? I mean, it sounds so minor, right? Well, the reality is a whole lot more dramatic than you'd think.
If the time is wrong, the digital world just breaks. It's a total domino effect. Security systems can't validate anything, financial trades get rejected, data starts getting corrupted because none of the timestamps match up. You might not even be able to log into your computer at work. It's a cascade of failure, all because the clocks don't agree.
So how do we prevent all this chaos? Well, we do it with a brilliant and honestly an often overlooked protocol. Let's meet the official timekeeper of the internet. NTP, the Network Time Protocol. Okay, so in simple terms, NTP is a universal language that all our devices use to agree on the exact same time. But here's where the magic is. It's designed specifically for the messy, unpredictable internet. It doesn't just ask, hey, what time is it? It cleverly measures the network delay, the round-trip time of its request, and then it accounts for it. This lets it sync clocks with incredible accuracy. We're talking down to the millisecond, even across entire continents.
So how does this actually work on a global scale? It's not like there's one giant clock in the sky. Instead, NTP uses this really clever hierarchical system. We can think of it like a pyramid, to spread the correct time accurately and reliably across the entire planet.
And the key to understanding this pyramid is a concept called Stratum. Just think of it like a ranking system. The lower the stratum number, the closer you are to the original, super precise source of time. And that means the more accurate your clock is. Simple as that.
And this just illustrates the flow perfectly. Right at the very top, you've got Stratum 0. These are the gods of time. We're talking atomic clocks and GPS satellites. They're the ultimate physical source. Then, directly connected to them are Stratum 1 servers, the most accurate timekeepers on the internet. They pass the time down to Stratum 2 servers, who then pass it to Stratum 3, and on it goes, cascading all the way down until it finally reaches your laptop.
All right, so that's the global picture. Now let's see how this whole system scales down right into a place many of us are pretty familiar with, the corporate office network, especially one running on Microsoft's Active Directory. Because in this environment, time isn't just important, it is everything.
Now, your personal laptop at home probably just reaches out to a public time server on the internet. But a computer that's joined to a corporate domain, it does something completely different. It doesn't look to the outside world for the time. It looks inward to its local domain controller. So why the difference? It's because the domain itself has its own designated master clock. This special job, called the PDC emulator, I know it's a mouthful, stands for Primary Domain Controller Emulator, belongs to one specific server. That server becomes the single source of truth for time for every single computer on that network, and it's the only one that should be syncing with an external high stratum source.
So why is it so strict about this? Why all the fuss? Well, it all comes down to the security protocol that basically runs Active Directory. Kerberos. And you can think of Kerberos as the network's bouncer. And it is absolutely obsessed with time.
And this is the crucial number, 5 minutes. By default, if your computer's clock is more than 5 minutes out of sync with the domain controller's clock, Kerberos will refuse to authenticate you. That's it. Your login fails, access denied, all because of a tiny 5-minute disagreement.
And that brings us to what happens when this really carefully balanced system breaks. Because, misconfigurations or failures in NTP, they aren't just theoretical problems. They cause real, hair-pulling headaches for IT folks every single day.
I mean, take this story. It's a classic tale from the trenches of system administration. You've got this mysterious phantom bug. It's preventing users from logging in. 3 days. 3 days are spent chasing ghosts in the code, in the network traffic, and the cause? A simple 7-minute time difference between two servers. Just 2 minutes over that Kerberos limit.
And the pain points are just everywhere. Authentication fails, so users are locked out. File timestamps get completely unreliable, creating data integrity nightmares. And your security logs, they become a confusing mess, making it impossible to reconstruct what happened, which is a massive compliance risk. Even the poor process of Active Directory replication can fail. It really is a silent killer of productivity.
So for the SysAdmins watching, these commands are your absolute best friends for troubleshooting this stuff. On Windows, w3tm/query/status will will tell you exactly where your computer is getting its time from and how far off it is. If you spot a problem, W3TM/resync can force an update right then and there. And over on Linux, Chronix Sources, or the classic NTPQ-P, gives you this rich, super detailed view of all the servers your machine is talking to, their stratum, the network delay, the offset, all crucial for figuring out what's wrong.
So, it's really clear that NTP is way more than just a utility. It's a foundational pillar of our modern internet, just quietly working away in the background. And what's truly amazing is just how long it's been doing that job.
Just think about that for a second. NTP was first implemented in 1985. 1985. That is before the World Wide Web even existed. It was built to solve a fundamental problem way back in the earliest days of the internet, and its design was so robust, so solid, that it's still the standard we all use today. That resilience is just truly remarkable.
So, the next time you log into your computer, or you send an email, or make an online purchase, just remember the unseen clockwork. Remember this elegant, decades-old protocol that is constantly negotiating with time itself just to keep our digital world in sync and working correctly.
And that really leaves us with a final thought, doesn't it? NTP is just one of these foundational invisible systems. It kind of makes you wonder, what other unsung heroes are out there, silently ticking away, holding together this incredibly complex digital world that we all depend on?